Good day. I'm Charby Danyoso, and my topic for today is all about regression analysis and Pearson R correlation. First, I will be discussing about regression analysis. Often professionals want to know if there is a relationship between two or more variables. For instance, is there a relationship between the grade on the third French exam that student takes and the grade on the final exam? If yes, then how is it related, and how stronger regression can be used here to arrive at a conclusion? This is an example of bivariate data, that is two variables. However, statisticians are most interested in multivariate data. Regression analysis is used to predict the value of one variable with dependent variable on the basis of other variables that independent variables. In the simplest form of regression, linear regression works with one independent variable. The formula for simple linear regression is shown on the screen. We'll look for a few examples of regression analysis. Regression analysis is used in several situations, such as those described on the screen. Example number 1. Using the data given on the screen, we have to analyze the relation between the size of a house and its selling price for a real estate agent. And example number 2, we need to predict the exam scores of students who study for 7.2 hours with the help of the data shown on the screen. Example number 3. Based on the expected number of customers and the previous day's data given below, we need to predict the number of burgers that will be sold by a KFC outlet. Let's look at the two main types of regression analysis: simple linear regression and multiple linear regression. Both of these statistical methods use a linear equation to model the relationship between two or more variables. Simple linear regression considers one quantitative and independent variable x to predict the other quantitative but dependent variable y. Multiple linear regression considers more than one quantitative and qualitative variable to predict a quantitative and dependent variable y. In simple linear regression, the predictions of the explained variable y when it's function of the explanatory variable x from a straight line. The best fitting line is called the regression line. The output is a function to predict the dependent variable on the basis of the values of independent variables. The dependent variable is continuous and independent variable can be continuous or discrete. Let's look at the different kinds of linear and nonlinear analysis. Lists of linear techniques are simple: method of least squares, coefficient of multiple determination, standard error of the estimate, dummy variable, and interaction. Similarly, there are many nonlinear techniques available, such as polynomial, logarithmic, square root, reciprocal, and exponential. To understand this model, we'll first look at a few assumptions. The simple linear regression model depicts the relationship between one dependent and two or more independent variables. The assumptions which justify the use of this model are as follows: linear and additive relationship between the dependent and independent variables. The equation for this model is shown on the screen. A more descriptive graphical representation of simple linear regression is given on the screen. Beta naught represents the slope. A slope of two variables implies that one unit change in x results in a 2-unit change in y. Beta 1 represents this estimate change in the average value of y as a result of 1 unit change in x. Epsilon represents the estimated average value of y when the value of x is 0. So next, Pearson R correlation. What is Pearson R? It is the most common method to use for numerical variables. It means it is under quantitative researches. Under correlational analysis, if your research design is correlational analysis, one of the tools that you can use is Pearson R correlation. It is a measure of the strength of the linear relationship between two variables. It means that this tool will be able to help you to determine the significant relationship of two variables. You are going to determine if one variable affects the other. The correlation coefficient takes on the values ranging between -1 and +1. That means your answer must be from -1 to +1 only. If you go beyond 1, it means your answer is wrong. Let's now try to determine or identify the types of correlation. Number 1, positive correlation. When we say positive correlation, it means as one variable increases, the other one also increases. Number 2, negative correlation. When we say negative correlation, it means as one variable increases, the other one decreases. On the other hand, as one variable decreases, the other one also increases. One good example, waiting time and customer satisfaction. When you are going to a restaurant, as your waiting time goes longer, your satisfaction becomes lower. Number 3, no correlation. It means one variable does not affect or there's no effect on the other variable. This is the formula to be used in person R. So, let's try to have an example. We now have examples of service quality and customer satisfaction. Service quality will be the value of X and customer satisfaction will be the value of Y. There are just only 4 steps in order for you to solve the value of person R or R value. The first step is fill in the table. As you can see, we have the values for X and we have the values for Y. We will be looking for the value of XY, the values of X squared and the values of Y squared. How? Let's try to follow the following steps. First step, to get the value of XY, multiply the value of X and Y. 4 times 5, that's 20. 4 times 4, that's 16. 5 times 5, that's 25. 5 times 5, that's 25. And 5 times 5, that is 25. Next, to get the value of X squared, multiply the value of X by itself. First, 4 times 4, 16. 4 times 4, 16. 5 times 5, 25. 5 times 5, 25. And 5 times 5, that is 25. That could be the next step. The third step, to get the value of Y squared, multiply the value of Y by itself. Just what we did a while ago. 5 times 5, 25. 4 times 4, 16. 5 times 5, 25. 5 times 5, 25. And 5 times 5, that is 25. Next step, to get the values of summation of X, summation of Y, summation of XY, summation of X squared, and summation of Y squared, add all the values on each column. It means we will be adding all these scores, all the values, then that would be the answer for the different values. First one, 4 plus 4 plus 5 plus 5 plus 5, 23. 5 plus 4 plus 5 plus 5 plus 5, 24. 20 plus 16 plus 25 plus 25 plus 25, the answer will be 111. 16 plus 16 plus 25 plus 25 plus 25, the answer is 107. Summation of Y squared. 25 plus 16 plus 25 plus 25 plus 25 is 116. It's a very easy to fill in the table. Just simply follow the steps that I give on the screen. As you can see, we will be using summation of X, summation of Y, summation of XY, summation of X squared, and summation of Y squared on the following. Formula. This is the formula, and these are the values a while ago that we got. So we will be substituting this value. We will be putting the formula, and it goes like this. So, N is total number of pairs. Pair scores, a while ago we have 5 pairs, that's why 5. So, we have summation of XY, that is 111, summation of X, that's 23, summation of Y, that's 24, total number of pair is 5, summation of X squared, that is 107, summation of X squared, we will be getting the squared of the summation of X, that's 23, total number of pairs, that's 5, summation of Y squared is 116, the square of the summation of Y, that's the next step. Substitute the values. On the given formula, first step, fill in the table. Second step, substitute the values on the given formula. After we substitute the value on the given formula, that is the next step. Solve for the value of r. As we can see here, we already substitute the value a while ago. So we will solve this one using the following steps. There are several steps to do in order for you to solve the value of r. Number 1, multiply. We will be multiplying 5 times 111. 23 multiplied by 24, 5 times 107, minus the square of 23. 5 times 116, minus the square of 24. It means 24 times 24, 23 times 23. And the answer would be 5 times 111 is 555. 23 multiplied by 24, that is 552. 5 times 107, that's 535. 23 multiplied by 23, that is 529. 5 times 116, that could be 580. 24 times 24, that could be 576. That's the first step, multiply. Second step, you subtract 555 minus 552, 535 minus 529, 580 minus 576, and the answer are like this. 555 minus 552, that is 3. 535 minus 529, that's 6. 580 minus 576, that's 4. Next step, number 3, multiply. 6 times 4 is 24. The next step is multiply. Multiply the denominator. 6 times 4 is 24. After you multiply, you get the square root of 24. The square root of 24 is 4.898979. I tried to use 6 digits decimal point in order for us to arrive the answer. If you will be trying to solve this one directly on a calculator, so we now have 3 over 4.898979. And the last step will be divide. We will be dividing 3 by 4.898979. And the answer is 0.612. And that is the answer for the r value. So don't forget the steps. The first step will be fill in the table. Second step, substitute the value on the given table. And number 3, solve for the value of r. In order for you to solve the value of r, we just need to follow the steps. Number 1, multiply. Number 2, subtract. Number 3, multiply the denominator. Number 4, get the square root. Number 5, the last one is divide. We now have the value of 0.612. The question is, what is 0.612? What is the strength of relationship of 0.612? That's the last step. Determine the strength of the r value that we had a while ago. So in order for us to know the strength of relationship, we have here the r values. If your r value is less than 0.30, it means the strength of relationship is none, or very weak relationship. Next, if your r value is greater than 0.30 and less than 0.50, so you have a weak relationship. The next one, if your r value is greater than 0.50 and less than 0.70, you have a moderate relationship. And the last one, if your r value is greater than 0.70, that means you have strong relationship. Okay, we have now the r value 0.612 or 0.612. The strength relationship on this is moderate correlation. It means service quality and customer satisfaction based on the example have a moderate correlation. It means they are moderate correlated to each other. It means there is 61.20% correlation between the two of them. Let's now try to review the process. Let's now try to review the process that we have. The first one is we need to fill in the table. Next one, substitute the values on the given formula. Number 3, solve for the value of R. And the last one, determine the strength of relationship. Well, that is all I have for today. Thank you for your time and attention, Ma'am Jocelyn. Thanks for watching and God bless.